Welcome to Hot Chips 24. Keynote 2, the future of wireless networking.
My name is Anwar Galoom. I'm from NVIDIA. I have the pleasure of introducing this next keynote. Our keynote speaker is Dr. Marcus Weldon, corporate CTO for Alcatel-Lucent. He's also a member of Bell Laboratories. In the last couple of days, we've seen a glimpse of some of the technologies that are really driving the next generation of computing, especially mobile computing. In this vein, Dr. Weldon's keynote will be the future of wireless networking. Dr. Weldon holds a bachelor degree in both chemistry and computer science, as well as a PhD in physical chemistry from Harvard University. He joined AT&T Bell Labs in 1995, winning several scientific and engineering society awards for his work on electronics and optical materials. In 2000, Dr. Weldon started work on fiber-based broadband access technologies, and in 2005 became the CTO for Broadband Solutions Business Group in Lucent Technologies, with responsibility for wireline access networks and IPTV. He was subsequently appointed CTO of the Fixed Access Division and the Wireline Networks Product Division in Alcatel-Lucent, following the merger of Alcatel and Lucent in December 2006, with responsibility for DSL, FTTH, IPTV, home networking, and IMS. He's one of the primary architects behind the evolution of the triple play service delivery architecture to the high leverage network, now the widely accepted industry architecture centered around the principle of all IP, converged wireline wireless, intelligent optimized networking. Together with the CTO team, he was also a primary driver behind the groundbreaking and multiple award-winning light radio architecture for next generation wireless networks. He continues to help drive the company in new portfolio directions, including defining new cloud networking and network as a platform paradigms, as well as the use of sophisticated analytics for optimizing the customer experience and service delivery. Please join me in welcoming Dr. Weldon.
Hi there. It's great to be here. This will be a bit of a different talk to the ones I was here for the last session. I will talk about chips at some point, but way towards the end, so you're going to have to be awake still, which will be challenging given the hamburgers and the wine. But before I start, I'd like to say this is my first time at Hot Chips. When I told my wife I was coming here, and she normally lets me travel more or less wherever I want, she said, "I don't think that's a good idea." I said, "Well, what's wrong with that?" And she said, "You're going to a conference called Hot Chicks." And I said, no, it's Hot Chips with a P. But in order to prove that, she was still skeptical. So in order to prove that I am actually not surrounded by hot chicks, I'm afraid I have to take your picture. So here we go. Smile, everyone. She will be greatly relieved. But actually, this device is going to be part of my story. This device is going to be part of my story here, because this is actually a transformational device. It's a Cupertino device, as you all know, at least in design. And it really is a device that changes the game. And I'm going to talk a lot about this device and what it does in terms of the requirements on networking, what it does in terms of needing the cloud, and how those three things come together. And of course, it is an inherently wireless device. There is no Ethernet port on this device. It has Wi-Fi, mine has 3G, the new iPad obviously has LTE, but it is a wireless device. My kids, when they use this, have no concept that the behavior should change when it moves from the home environment to a nomadic environment, for them, school, to a mobile environment being in the car. It should all be the same because they've changed nothing. And so that's a very important concept that I'm going to talk about, because there's a whole generation of people that expect this to behave the same anywhere, anytime. There's also another interesting characteristic of this device. that it's expensive enough that you won't have two of them, and big enough that you won't have two of them. You won't do the work cell phone and private cell phone. You will have one of these things, and it will span both home and work. So you will have the blending of home and work through this device, as well as the blending of home, on the go, and nomadic through this device. And it, frankly, will leverage both cellular and Wi-Fi technologies as well. So it really is a transformational device, and I'll talk a lot about that, because it impacts the network, it impacts what network components have to be able to do, and the capacity we need in the network. And even to the point of driving the capacity of mobile networks up by maybe a factor of 80 or 100 in the next 5 years, which is going to be a great challenge on the radio access part. So there's going to be a lot of focus on high-order processing of that. But even for the backhaul of that, if we could compress that, if we could optimize the transport of content to and from the radio access node by using higher-order compression, that would help on the backhaul characteristics. So all of that is going to come from thinking about this device that I just took your picture with. So I'm going to answer actually 3 questions. What is really driving the wireless market? And the future of networking, I've hopefully explained, is all about wireless networking. Wireline is important, but really the interface that people care about is wireless. And since it's the most constrained resource we have, depending on your religion, independent of religion, you could almost say, there is no more spectrum. It's a god or some sort of omnipresent figure made allocation of wireless spectrum that you can't recreate. So it's the most constrained resource, given the propagation characteristics and the amount of spectrum we have available, that will exist for the time, for the foreseeable future. So because of that, wireless networking, the radio access piece, is a particularly important part of what we think about. And of course, this device being a wireless-only device couples those two things. Then I'm going to look at where is the real value. Is the real value in this thing? Is it in the data center? Is it in the network? Or is it in all 3 of them? And how will the functionality play out between those 3 things? And then I'll talk about what I think will be the new reality. So I'll talk for about maybe 40 minutes. Hopefully it'll be fun. Normally I do this interactively, but it's going to be difficult in this auditorium. So I'll leave plenty of time for questions at the end so we can go back and forth. Since this is going to be sort of a vision talk, you should be skeptical about large parts of it. And I expect you to raise your objections at the end. So let's start by what's really driving the wireless market. And I'll start with some fun statistics. It's just to get you warmed up, but they actually are relevant too. So these are the statistics I'm going to highlight. By the way, we've coined this term, the tablet generation. And our CEO actually coined the term. And what he means by it is a generation that is not defined by age, but by behavior. The tablet generation, I have a 2-year-old and I have a wife who's somewhere older than that, and I have parents who are older than that. They all use tablets. They all use them actually for a remarkably similar set of things. So the tablet generation is ageless. It's a behavioral generation, and actually most age groups behave similarly and use tablets in similar ways, and I've begun to describe what those are, and we'll talk about it a little bit more. So the tablet generation is a transformational generation that uses this thing to do everything, anywhere, anytime. But let's look at how much they rely on mobile networking and mobile devices. So I start down in the bottom left-hand corner here. Ooh, they gave me a big pointer that they warned me not to point at you because you would be blinded. So here it is. Apparently I shouldn't take it to the airport because I could blind the pilot with this as well. But here we go. Let's start with this one. We normally ask the audience, how many of you actually sleep with your smartphone? And I won't ask whether it's in bed or on the bedside table. It just has to be in the bedroom. So how many of this audience sleeps with their smartphone? See, there's your 66%. You are officially American citizens. That was a citizenship test. Germans, they actually have a greater affinity for mobile broadband than they do their spouse, and maybe you could understand that, but they also, their car, which to me is a remarkable thing for Germans. And the UK, mobile broadband matters more to them than anything. which says something you may tell from my accent that I'm actually English. It says something rather depressing about the UK enthusiasm for anything other than web surfing. So, but what it says is there's a strong affinity for the mobile broadband experience. I had it actually said another way by a Chinese woman to me. She said that she looked at her smartphone at the time, but it'll soon be a tablet, as an extension of her hand. In fact, she implied that she would give up a hand if it could be replaced by a utilitarian mobile broadband device. She also said, and this is the slight conundrum in all this, that she viewed the network as like her mother-in-law, which again is a variably good or bad thing. The point we have here is we have a device that is perceived very positively, but its functionality is inherently dependent on a network, and I will argue cloud, and connecting those two things, yet the perception of the network is a very negative thing, or at least a highly variable thing. So we've got a conundrum there where we need to shift a value proposition, and it's not just for the sake of some sort of equanimity or fairness from a technological point of view. If we don't shift this value proposition, we won't be able to build the network that delivers the services that users expect. So I'm going to talk a bit about that. If we look at some of the other statistics up here, 70% of users now in developing nations are mobile-only broadband. That means they just have a dongle or a cell phone as their only means of communication. In the US, it's already 25% is mobile-only broadband, and that's teenagers, college kids, new graduates, all just using mobile broadband. And you can argue with the new iPad, which is LTE-enabled, you could perhaps do away with home connectivity in its entirety and just use an LTE-enabled iPad with Wi-Fi for nomadic purposes. And I'm going to talk about networks that may make that a reality, where wireline becomes just the backhaul network for wireless, but in itself is not a connection service of its own right. In developing nations, it actually is more than just for entertainment purposes. Of course, it's transformational from a cultural point of view, and that I think we're fully aware of. One of the key things, and the reason I have Facebook up here, again, very well known to you, is that the one thing that Facebook does well is make itself available as a platform for consumption by media, content, and people. What the network does poorly at the moment is make itself available as a platform for consumption by media, content, and people, because it's typically operated as a walled garden with not much exposed in interesting ways that could be consumed by developers. So we need to change that, and I'm going to talk about the network as a platform. Concurrency is an important topic. Media gets consumed on these devices in highly concurrent ways, which is why you can consume 11.5 hours of content in 8 hours. It's the idea of constantly consuming, having a video chat session, streaming video, maybe even have a gaming component to that streaming video session, web surfing, file uploading, downloading. These sessions are all relatively long-lived, overlap in time, and are a huge multiplier in terms of the load on the network. And I am going to talk about tablets. 100 million sold in 2012. The number by 2015 will be 500 million, which will be more than PCs. So by 2015, there'll be about 500 million tablets sold and about 400 million PCs. So in a short space of time, if you consider 2009, the launch date, within 6 years, this device will have taken over the computing world in terms of volume of compute sold. So let's carry on with this discussion of tablets. This is a very nice survey that I'll read to you just and summarize for you briefly. Nielsen, about 6 to 9 months after the first iPad came out, asked people, now you have this device, which of the other devices you own do you use less because of this device, and which do you use more? And to make it easy to view, I've put this line here where essentially where these blocks at the bottom are greater than the blocks at the top, people said that they use these devices listed here less now that they had a tablet. And remember, this is only 6 to 9 months after tablets were first emerging. And over here, the reverse is true. They said they used these other devices more now they had a tablet. So very loosely, and considering it was early days, you could conclude the following, that the tablet will actually replace these devices to the right of the line, and it will augment these devices to the left of the line. So let's look and see whether we believe it. So if you look at one of the first ones, gaming console, the new Wii, the Wii U, is a tablet-based gaming console. And increasingly, there's a sense that to tap the larger gaming market, you will actually consume games on a consumption device like a tablet, and it'll be rendered in the cloud. And the idea of having a fixed console that is only available in one room of your house to a set of expert gamers will be gone. And so you could argue that that one is already becoming a trend due to the new Wii. The portable gaming console clearly should go by the wayside if the gaming console does. Portable media player are those DVD players that you had in the back seat of your car that your kids took on planes, those little DVD players. Those clearly have died as a market to be replaced by a reasonable amount of storage on an iPad, and now with ultraviolet I can get any of my DVDs that I buy on the iPad and relatively easily ported. E-books. E-books have essentially become tablets already with the Kindle Fire and variants of that. So that market has already transitioned. Netbooks, those tiny little laptops that didn't even have a DVD player, that market died within a year of the iPad and tablets emerging. And I'd argue that desktop PCs have become essentially laptop PCs is where the volume is, and laptop PCs increasingly now are docked iPads with those little keyboards you get in those very nice folio covers. So it all makes perfect sense that this is actually how the world will be. There's no reason to have all these devices if, in fact, I can have a tablet, perhaps with a keyboard, that can access anything, anywhere, anytime. And on the left-hand side, let's look at what survives is a connected TV, because there's still a need for a large display device where I want to communally view something or I want to just view it writ large. So a movie is a certain experience I might want to watch large on a large screen. And a smartphone, because it's essentially a tablet, is still not quite portable enough. It doesn't quite fit in your pocket. It does have comms today. In future, tablets will have comms services. But smartphone is a form factor argument again. So you can argue that the connected TV is a big tablet, and I'll argue that with HTML5, where I'll have similar applications available written in HTML5 running on a browser, on a TV, on a smartphone, and on a tablet, it really does become that the connected TV is just a large tablet running the same apps as my tablet, and the smartphone is a small tablet that's just more portable. And GPS is just a function that people really like. They perceive it as a device today, but in fact, that's just a function. So broadly, this slide says everything will be tablet-based. It's the lens to the future is a tablet. I just need a big one sometimes, and I need a smaller one sometimes. But in future, the tablet is the thing that will define our experience. Now, why is this so important? It's a nice device. Why am I making a big deal about it? Well, it's because of the reasons I highlighted. It's a device that converges work and home. It's a device that converges home and on the go, because I do all these things at home, and since it doesn't have a wireline interface, I don't unplug a cable, I want to take all those things with me, because there's no logic that I shouldn't be able to take them with me. In fact, and when I go to a Wi-Fi network, I can take them with me, because Wi-Fi at home versus Wi-Fi on the go should look very similar. And then similarly, I want that available with a full mobile experience on a train, on a car, or whatever. So I want it available on cellular networks. So it converges home on the go, it converges work and home. So it's really a transformational device, and it's independent of age. So this device is essentially a life convergence device. It's a device that will allow you to take everything you do and own and the experiences you want to have anywhere you want to go. This is a key point, because if we believe this, the future looks nothing like today. There are these extrapolations of bandwidth growth where people say it's growing 50% a year, maybe 100% a year. But in fact, that's just based on web surfing, texting, and a little bit of YouTube video streaming. And Pandora, by the way, on mobile networks today, the biggest consumer of bandwidth typically is music streaming. So that's an interesting one, because in fact, that's an application that you can do anywhere, anytime, because you don't need to be looking at this. And that already, although it's not an incredibly high usage service in terms of number of users, maybe only 10% of users, it's consuming 50% of the bandwidth on mobile networks and some mobile networks because it's always on. There are people who drive to work using a Bluetooth interface from their phone through their car stereo that are streaming Spotify, Pandora, whatever, and using that as their music service over a mobile network. And this is just the beginning. It's the only application today that would be in line with the type of applications I'm describing for the future. So a very important shift. And we can come back to that and you can debate this with me, but this is the shift, and it's going to drive big changes in the mobile network. So we built a model. I own some part of the Bell Labs team, so I asked them to build a model of if, in fact, there's a tablet generation that's coming, what type of network would I need to build, what capacity, and what type of network, macro, metro, Wi-Fi, etc., to satisfy the need. So they actually looked at all these applications that you might want to, you consider about communications applications, video streaming, content sharing applications, gaming, cloud compute applications, and they built a model. And they did it for different demographics based on census data of where you were at different times of day for different age groups. And they built a demand model that says in the next 5 years, the most aggressive version of it is there'll be 85x growth in mobile capacity. It's mobile demand only. It doesn't have the supply side built in. It's simply what is the nascent demand that we would like to build to if we could afford to. 85 times growth. That's a big number. If you look at the other interesting part of this is how do I consume that data? The good news, in some ways, is that Wi-Fi at home solves half the problem. Because Wi-Fi at home is abundant because it's got a reuse factor of every home, subject to interference from your neighbors. And Wi-Fi at home solves half the problem. And it's as simple as this. You are awake and active for 8 hours of the day at home, about 8 hours of the way away from home, and you're asleep for about 8 hours. So it's as simple as sort of Wi-Fi is the interface of choice for about half your number of active hours. But then, Wi-Fi isn't enough at home, right? Because I'm only there for 8 hours. So now if I want to go mobile, I can use two interfaces. I can use a cellular interface or a Wi-Fi interface. And we mapped that out based on quality of service. For low mobility, nomadic type services that didn't need quality of service, we allocated to a Wi-Fi interface. And if it was a higher mobility, quality of service enabled function or service like gaming or cloud compute, we put it on a cellular interface. And then we decided whether or not you could satisfy it with a macro network or a metro network, and I'll talk more about metro networks. And you see, metro cell networks, a new form of wireless network that is based on small cells, will actually solve half of the wireless problem away from the home. So the home takes care of half the total problem. Of the remainder, small cells will solve half the problem. Macro cells will solve about a third of the problem. And the remainder, this thing, smart loading, is the idea of you can reduce your peak capacity requirements by virtue of having pushed content in advance predictively to the end user by using sort of forward push and caching to the end device. So these are the techniques that will actually allow us to build a network with 85x growth in wireless capacity. Half of it comes from Wi-Fi at home. Half of the remainder, so a quarter of the overall, comes from new small cells that will be deployed. About a third of the remainder, so about a sixth of the overall, comes from macro, and the rest comes from intelligent push of content in advance of the peak demand all the way to the end device. So this maps out the future of wireless. It's about metro cells, it's about pushing content smartly and processing content in the end device, and it's about macro cells, but to a decreasing extent. And if you think about it another way, it's obvious, right? When you go to capacity-constrained networks, when you need to build an ultra-high capacity network, you always go close to the end user and do reuse one of the resource that you have, because that resource typically attenuates with distance, and so you reuse it over and over again with shorter and shorter distances. When you're in a coverage world, which is where we've been to date, you do the opposite. You go as far away from the end user and have the minimum signal strength to some extent, is the most economic way to provide a coverage network. For a capacity network, you have to go as close as possible to have the right economics at the capacity requirements that you need. So we're in a new paradigm driven by the tablet generation of moving to a capacity-driven world dominated by Wi-Fi and cellular technologies on small scale, away from a coverage-driven world, which is where we've been to date. So it's a radical transformation. So let's focus on this. I really want to emphasize that there is no other answer, because if you're thinking about chipset designs going forward, all of the interesting chipset designs will have a strong emphasis on metro cell or small cell, as well as having a macro cell variant for the point I've just made. So in order for you to believe this, I'm showing you fundamentally the levers you can use to deliver wireless network capacity. So this is the set of things you could do. The things in blue are you could try and expand your existing macro cell network by cell splitting. This is the idea of taking a single macro site and halving its serving area and reusing that on a macro basis. And you can think of that as a version of small cells. But the problem with macro sites is that they're big, ugly, and everyone objects to them, and because they are so unsightly. So that is a very costly process, and generally only gets you a factor of 2. The other thing you do is get more spectrum. But if you look at the amount of spectrum that's already allocated versus what is unallocated, there's only about a factor of 2 in that as well. So these 2 effects might get you between them, say, a factor of 2, maybe a factor of 3. That's sort of a conventional macro approach. In the purple are physics or engineering, where I can do lots of interesting things at the radio layer. I'll name them for you because you're probably not familiar with all the terms here. Carrier aggregation is simply the idea of taking a wireless frequency band here and a wireless frequency band here and treating them as single contiguous carrier. So all it does is give you a higher peak capacity, because the assumption is that both carriers are already full. The difference is if I can treat them as a single contiguous carrier, I can burst up to twice the bandwidth and give someone instantaneously the full double carrier bandwidth. Rather than half of the carrier bandwidth. So it allows me a peak capacity, but it doesn't give me anything really in terms of the average capacity, which is why the gain is relatively small. In MIMO, I can increase the transmit diversity, but in fact it's already quite a diverse system in most cases. And so I'm only going to get a factor of 20% by going into higher order MIMO at this point in time. EICIC is enhanced intercell interference cancellation. The idea, if I can manage my, in LTE with an OFDM modulation scheme, I can actually frequency select so that neighboring cells don't interfere with each other. And if I do that well, I can get about a factor of another 20% relative to not having that capability. And then last, I can do coherent multipath. And coherent multipath is the idea that you coordinate transmission from multiple cells to a single mobile. And yes, there are different forms of it. In the most ambitious, you actually constructively add the 2 signals in phase, and you get an improved signal-to-noise ratio by that constructive addition, basically within one cyclic redundancy symbol. If you don't do it within that symbol, you're basically it's an additive process, not a multiplicative process. And on average, you get something on the order of 20% in most cases. So all the clever physics, and by the way, release 11 means products in 2013-14. So overall, if I look at all the physicsy parts, I can get maybe 20% across each of them, and a factor of 2 perhaps if I do them all. So all I'm left with is the idea of reuse 1 on a smaller area. It's what cable networks have always done by node splitting. It's what DSL networks have done by moving closer to the end user with VDSL and fiber to the node architectures. And it's just the same principle applied to wireless networks. I move closer to the end user. My attenuated RF spectrum, therefore, is less attenuated, and I reuse over a smaller geographic area and reuse over and over again. So that's my gain. My gain can be n, where n is any number. It's the number of metros per macro. So it's a huge factor in principle. And then on top of that, once I've gone that small, I can do AAA. AAA is adaptive antenna array, and it means I can form beams. So if I'm close, I can form meaningful beams by pointing the radio power at the hotspots of activity. Imagine it being around a traffic light, around the exit from a building. I can actually steer the beam to put the maximum radio power right where the people are, as opposed to flooding it in a broad spectrum or broad swathe across space. So that can give me another factor of 2 on top of that. And this really is all that's available. We're at the Shannon limit per single channel within 20%, so there's no more to gain on a single channel. All we can do is manage the interference, look at using multiple channels, and all of those effects don't give you anything like the 80-fold growth you need. Small cells are the only way we can do that. So I summarize it very simply in this. If I look at the macro approach, I could go with more spectrum and more sites, and maybe I get a factor of 2. If I go with the physicsy engineering approach, I can get more spectral efficiency, more bits per second per hertz, and maybe I can get a factor of 1.5 to 2 from all those purple factors. But if I use more spatial efficiency, the idea of reuse 1 over a smaller area, I can get any number I want, and certainly greater than 10x, and we've already deployed networks that show you can easily get 10x by deploying in the right way. So across all these factors is the future of wireless networking. Hopefully very clear. And I've presented this now probably 20, 30 times to operators, analysts, general broad thinkers in terms of wireless networking. No one disputes this. This is sort of a fundamental truth of networking. So you ask, well, if it's a fundamental truth, it's always been true. And that is true. It's always been true that this has been true. The difference, though, is before we were in a regime where we only needed to do this. We only needed to do the physicsy things and the macro coverage type things and use macro as a way to increase capacity as best we could. But with the tablet generation, we're in this regime. It was a regime that was uninteresting and speculative before, but now it's the regime that we must move to. And that's going to be the huge transformation in wireless networks, is moving increasingly to small cells with macro just used for infill between small cells. So a big shift coming. Now, the problem with all that, it's a nice story, but it costs money. So we have to look at the question of, can we afford to build this network? So here is a plot of mobile operator revenue, as well as fixed operator revenue. So fixed is at the top here with both data and voice, and here's voice and mobile data. And you see that it's not a very good outlook for operators. Their revenue is, in fact, declining. The best they've got is mobile data, which is stable. And when you look at this, you'd say, well, that's not a business I want to be in if I'm inexorably declining revenue. But it also allows you to understand what Verizon and AT&T did recently. Seeing mobile voice declining, and declining very rapidly to the point where it had almost no value, they bundled it together with mobile data to have these all-you-can-eat messaging, voice, and data plans, and as a result, ticked up the mobile data. So they quickly added this in and pushed this up, because this at least is flat. The way they were going, you can see 2012, mobile voice was actually going to be less valuable than mobile data. So they quickly combined them and pushed this up. And it's a very logical thing to do when you see these revenue curves. They stabilized their revenue model as best they could. The problem we have here for vendors of equipment, for makers of chipsets or designers of chipsets, is in this revenue regime, since the OpEx is only increasing as a fraction of revenue because they're actually running multiple network types and having to upgrade networks with quite high frequency, meaning every few months, the typical number is every time they add a carrier, which is a carrier is a fraction of a mobile spectrum band. So if I own an AWS carrier, I might have 4 of them in the AWS band. Every time I add a carrier in a city like New York, it lasts 3 months before it's full. 3 months. So that's what's happening. So you can imagine that the expense of deploying a carrier, managing that carrier, adding that in, is consumed only or amortized only over a 3-month period. So OpEx is only going up. And so CapEx pressure is inexorably put upon us and chipset manufacturers too, because it's the only thing that they can control. And even by being fairly aggressive on CapEx, their OP as a function of revenue is going down. The operating profit as a function of revenue is decreasing. And you'd say, okay, it's still at a fairly healthy level, even for companies in Silicon Valley. An operating profit of 15% is a good number. But look at the trajectory. 2012, 13, 14, 15, they're a declining operating profitability set of companies, and that's not a good thing for your market cap. So they have to stop this decline, and as we see, the decline is only going to continue. So we have this conundrum. Users and the tablet generation want a network with 80 times the capacity, but they're not willing to pay for it, it seems. So we've got to find new revenue models that actually readjust the balance and the value chain from being perceived as entirely in the end device, a $700 tablet, and shift it back towards the network portion and, to some extent, the cloud portion. And that's where I'm going with the rest of my talk. So where is that value? Well, ultimately, when you think about it, there are three fundamental components to value. There is the tablet, but it's just an experience delivery device and consumption device with very little processing. It has some processing, but it is like an 8-year-old PC. I looked again at the numbers recently in terms of its memory and processing power. It's roughly an 8-year-old PC. It also doesn't have the storage capacity of a modern-day PC device. It's typically 64 gigabyte because it's a mobile device. It has limited weight, or it has to fit within a certain weight requirement, a certain power requirement. And so it only has 64 gig of storage capacity at the moment, and that certainly isn't enough to store your life. So this is where the cloud comes in. The cloud comes in by providing the additional processing power to top up an iPad and make it much more than an 8-year-old PC. In fact, make it like a supercomputer by having the content and media processing capability and storage capability in the cloud. So best media, apps, content, and storage in the cloud. But in between, this proposition of tablet connecting to the cloud to store and manipulate and stream your life to you, you need control over the network. And you need very tight control of the network for the types of applications that are coming, and that's what I'm going to talk about. So there really are three values. There's the consumption device, the storage and compute device, and the delivery device or entity, which is the network. So let's look at this in a little more detail. Here's the three devices that I say will exist: a smartphone, a tablet, and a big screen TV. And there's value perceived here. There are 5 canonical applications, I think, that define the future. And you can make any application as a hybrid of these applications. But fundamentally, we all need to compute, store, stream, game, and communicate. And if you combine these, it captures pretty much everything we do as a set of services that we consume. Now, if I look at them, pretty much today we've been somewhere doing a little bit of web surfing, if I put that in computing, and a little bit of storing of media and a little bit of streaming of media. But most of the things we've been doing just require a reasonable amount of capacity. But they are not latency-sensitive applications. They are capacity or bandwidth-sensitive applications. And so the network has been managed to be sort of adapted, or the applications have adapted themselves to the limited capacity of the networks by using techniques such as adaptive streaming and higher-order compression to live within the bandwidth constraint of the network. But if you look at the future, 3 of these applications require latency control. Really, virtual desktop or high-order compute or gaming in the cloud or guaranteed level comms, not just sort of best effort comms, the type of comms that will give you that truly immersive experience, all require, well, in the case of compute, 50 millisecond latency, 30 millisecond latency, gaming, 60 millisecond latency, communications, 100 millisecond latency. And if I look at EC2, Amazon's EC2 cloud, by not controlling the latency and just having it as a best effort approach to the simple queuing service and the propagation to their cloud and within their data center, they have published latencies on the order of 8 seconds. Now, it's not all the time 8 seconds. In fact, it's very little of the time is at 8 seconds. But can you imagine an experience where it's most of the time good, but 5% of the time or 3% of the time it's 8-second latency? That doesn't represent a service that defines your life or that you would trust your life with. So here, we finally have the chance for the network, because ultimately, latency is a network hop and propagation time problem. It's all that's in there. Physics of, or speed of light propagation in a dielectric media, and number of network hops. That's what's in latency. And the only ones who really actually control latency, therefore, are the ones who own the network and the number of network hops, which is where operators can come to the fore. So this is one of the new value paradigms. No longer is the network something that just you manage your application consumption of capacity despite the network. Now you have to actually ride in the network and be part of the network in order to deliver a low latency experience. So this is going to be one of the new value paradigms operators leverage. The other is privacy and security. These are the other dimensions of operator value as well as their billing relationship. I won't talk more about them now, but you see that the operator now, given that the number of web services actually are looking to minimize your privacy and provide no particular security, the operators are re-entering this race using metro cells as a delivery mechanism that offers low latency, private, secure communications and next generation services delivery to these three devices. So let's look further into this. What does it take? This is the new reality we see, and I'll then talk about the chipsets that should enable this. If you think about it, we have been for a little while in the digital world, where we have digitized a number of services. We've just come out of the analog world maybe 5 years ago, possibly 10 years ago, where we took physical goods like books and video and music that was sold in physical stores that we physically drove to, and then we physically owned and played the good. We have been in the partially digitized world, where, for example, we cannibalized music, we cannibalized books, the Kindles and so forth have taken analog media or physical media and made them digital media. And iTunes and iPods have done the same for music. And you can argue a little bit we've cannibalized video because there's no longer a Blockbuster floating around, and Netflix is trying to get rid of its DVD business. And we've gone to just digital delivery. But there's still a lot of digital delivery that needs to be done. And here's the change that's going to happen, and I'm going to show you a slide, that many, many, many industries still do not digitally deliver their product. And that's the revenue source that we can go after to fund this network build. And if you understand this, then you understand that optimizing the delivery of those new digital assets is actually where operators are going to have a play in terms of chipset functionality. They're going to be looking for things that actually allow them to facilely, optimally deliver media and content over mobile networks. I have a story that my CEO tells that's a good example. He had his 9-year-old grandson stay with him, and he said he offered to take him to the toy store and buy him absolutely anything he wanted. He's a CEO, so he makes a ton of money. He said, "I'll buy you anything you want." And he expected to spend a lot of time buying Lego, he said, that weekend. But his 9-year-old grandson said he wanted credits to a digital game, to Minecraft, actually it was. And so the CEO said, "Well, I don't even know what that is." And when it was explained to him, he said, "That's not even real." But to his grandson, credits to Minecraft was more valuable than any Lego set. So if you think about it, the toy store money, the Lego money, became digital money. Now, in that particular case, it didn't need any particular delivery, but there are many, many industries ready to be cannibalized that will take the analog experience that we are used to today, and we will digitally deliver them using ultra-high capacity networks. So what are those experiences? And by the way, just to highlight here, software-defined networking I see as sort of an interim step. You've heard a lot about SDNs and the idea of separating control plane from the data plane in order that you can build cheap, low-cost switches and have centralized control plane that manages the policy and the forwarding rules in those switches. it's not a paradigm that's going to be particularly interesting because it treats the network and the forwarding plane as all packets are more or less equal, and I don't need to make any particularly intelligent decision on a packet-by-packet or flow basis, because if I did, I would never forward that flow to a central location, have it parsed, and then have the rules sent back to the end device. I would do the processing in a much more distributed way. So we actually believe in future everything will be application aware. And this comes down to baseband processing chips, for example, whether it be on the wireline side for digital signal processors for DSL, or digital baseband processors and SoCs for wireless, is the more media aware those chipsets become, the more intelligent the network becomes, and the better it is able to deliver different attributes of different services to maintain that high quality experience. So let's look at how we see things. If we look forward, the network becomes an all IP infrastructure. It's already there. It's converged between wireline and wireless already today, meaning that mostly all operators are moving to the model where the wireline network they built is now acting as the mobile backhaul network. And in some cases, the mobile packet core, which is the SGSN, GGSN, or in LTE terminology, S gateway and P gateway, is built on the same infrastructure as what was the BRAS function or the subscriber management function in a wireline network. So those networks have converged around an all IP infrastructure with just wireline or wireless access edges. But on top of that, there are three paradigms that the operators have that they're leveraging. They can control that network intimately. They can then optimize that network on a per application basis. And they're beginning to do more and more sophisticated analytics so that you can actually deliver the content per application, per user, per network connection type, even per cell type, meaning what is the capacity available on a given cell, and even what mobile device are you using, so can I deliver optimally to you. So the new paradigm is leveraging these network as a platform type characteristics. Here's the network, here's three platform layers, if you like, a control platform, an optimization platform, an analytics and decision platform to deliver new experiences. And these are the new experiences they will deliver as these high-order APIs the network exposes that delivers compute, storage, communications, gaming, and media, and any other service that can be defined as a network configuration through these platform layers. So that's the new paradigm they're moving towards. The network becomes a platform for experience delivery, and in that process, they will manage to monetize that network and therefore build the ATX capacity that users inherently want. So where is the money in this? So that's how it all comes together in a beautiful globe. But I want to show some data from someone else. There's a very clever woman who's at KPCB out here in Cupertino and Mountain View, who's been looking at internet trends. Her name's Mary Meeker. And she's begun looking at where's the money in mobile. And one of the things she still points out here is there are early trends that show that actually money is appearing in the mobile realm. And here is the yellow curve is mobile ARPU, the dashed curve is desktop ARPU over time. And this is in Japan for a gaming service, very relevant to NVIDIA and others here. This is a gaming service on a mobile device. And what they found is that over time, within the course of a couple of years, the average revenue per paying user for that gaming service was higher on a mobile device than it was on a desktop device. And the numbers are significant there, several $100s per year just for that service. There are many other services where she points out that if you look at the trending, mobile ARPU follows desktop ARPU, it's just 3 or 4 years after the fact. And that's sort of what she's showing here as well. It's not quite 3 or 4 years, but a couple of years after desktop ARPU has reached a certain level, mobile ARPU can reach that level. She also points out areas that she believes are ripe for reimagination or digitization. So these are the new areas, again, thinking broadly about what are the services that are going to be delivered over this network that we need to optimize around. These are the areas that she points out still have plenty of room for, she calls it reimagination in the tablet generation. If you look at the numbers, the market cap of these industries is 36 trillion. If you look at their EBITDA, it's on the order of 6 trillion. You only have to take a very, very small piece of that industry, less than 1% of that industry, and you're in a very interesting space of being at 60 billion in terms of sort of revenue potential if you can offer a delivery service that enhances that otherwise analog business experience. And that's the sort of model that operators need to move towards to fund this next generation network. My toy store example is just one of these examples. Gaming services, clearly you still have GameStop. GameStop should be gone. It should be, in future, a cloud-based gaming service delivered over a network with tight latency control to a tablet device. You still have newspapers that print and deliver manually. That business should entirely be a digital business. There are many, many other examples. Think of healthcare and all the records there that exist in paper that should be digitally available. We've been involved in discussions about putting metro cells around, small cells around a hospital so that doctors can carry tablets and have patient records with them wherever they go and pull up images and additional information rather than always having to go back to some central repository. So there's much to be done here. And although we're at this nexus of uncertainty, we've got to build a network that's 80x the capacity with no indication yet that users are willing to pay more, except just little glimpses of it from that gaming service in Japan and a few other places, where users, as we transform them to the tablet generation, their dependency on these devices and that experience being always on, anywhere, anytime, is going to drive new revenue models that make this future a reality. So I want to talk about chipsets a little bit, and this will be my last couple of slides, and then I'll open it up for questions, because this is ultimately what it comes down to, I think, for you guys and for us, is in the domains that we're interested in, which is sort of IP, optics, access, wireless, and network applications, here's what we have to do. It's a quest for both of us. We as equipment manufacturers have to actually design with these goals in mind, but chipset designers have to design chipsets that enable brand new experiences that are always higher performance, more efficient, less space, and lower power, and you know that as well as I do. So here's what we're doing in the IP space, and this is actually Alcatel-Lucent sort of specific stuff. We've just built our own third generation of a thing we call the FlexPath processor. It's our own ASIC. It's a 400 gig network processor, multi-core network processor with many, many compute cores and 400 gig of SerDes in there that actually is the highest order core routing packet processing capability out there on the market. Others were using EasyChip and MPUs or even FPGAs to do packet processing. We've been always in the ASIC space building our own network processor there as an ASIC, and that gets us to 400G with the capabilities that you see there. Power, 4x less. The weight, this is actually, I'll be quite clear just for the fun of it, this is a Cisco core router for about 32 terabits of capacity, and this is actually the Alcatel-Lucent equivalent by virtue of this component. Because we are in the silicon business, at least for network processors for core routing capabilities, we get 4x the power, a tenth of the weight, and 7x less space. And that's all because of the fundamental importance of that component. A very big deal for us. In the fixed access space, a lot is going on there actually in the silicon level. There's this technique called vectoring. Vectoring is interference cancellation for DSL. As you may know, DSL lines are just twisted pairs running in a binder. Those twisted pairs, the only shielding from each other is the twisting, and then they otherwise all run in the same binder. So there's very strong interference between those. This twisting is by no means a perfect isolation. But by doing signal processing on that, you can actually, of course, predistort the signal to take account of the interfering channels. So you do channel estimation, as you're very familiar with, of all the neighboring lines in the binder, and then you predistort the signal of interest to actually destructively cancel the interfering signal. As a result, DSL can now get to, it's been proven over 300 meters, it can get to 300 megabit per second. And that's all digital signal processing. And in this space, we actually had to build our own vectoring ASIC. It was Broadcom who was trying to be our partner in this space, but we simply ended up building our own ASIC there in order to get to market fast enough with the performance we need. And this is a big part, because it has to vector across all the lines in a DSL cabinet. The DSLAMs today have 1,000 lines in them, or 500 lines in them. And to make this work, because all those binders come into different ports, right? Because a cable binder, you've seen cable plant out there, those lines terminate anywhere. So in order to prevent a massive rewiring project, that DSP has to vector or do signal processing and cancellation across 1,000 lines at a time. And that's a big space there. If we look at optics, we'll go to wireless next. I'm going to talk a little bit about the SoC for wireless next, and you'll see why. But the SoC is going to be any technology, so any G means any generation of wireless technology, with high-order sort of capabilities, which means generally can support on the order of thousands of users per sector carrier. A sector carrier is, I have a carrier, I deploy it on a given sector. I have maybe 3 sectors on a macro antenna. So I may want 1,000 users per sector carrier. And so it has to have scalability in the core processing, as well as being able to create the symbols required to by the scheduler and launch them over the air interface. So any technology supporting carrier aggregation, the interference cancellation that I showed you before, all of that at 1,000 or more users per sector carrier is pretty taxing business. But by doing that, we get power savings that are significant and cost of ownership savings that are very significant. If we go to optics, you've seen something from the Xilinx presenter earlier on the Vertex 7 work they're doing. We also produce a photonic integrated circuit there that is a coherent preprocessor of coherent technology. It basically use orthogonal polarizations and higher order modulation schemes now, DPSK type schemes on 2 orthogonal polarizations, and you can get to 100 gigabit per second on 25 gigabaud of bandwidth. So those sorts of things we all do. We do that all in our own photonic integrated circuit to do the coherent processing at the types of bit rates we need. And then, of course, virtualization plays a role. That's where GPPs come in, general purpose processors, because, in fact, a lot of the time we're running software applications and not physical applications. So comms applications like voice processing and voice call control is essentially a software application just running today on dedicated hardware for no particularly good reason other than reliability, but increasingly that is moving to the cloud and increasing the utilization. This is a typical call load model. You see that you design for the peak call load. That's a concept that you're probably familiar with. So this is peak call time, but look at all the capacity that isn't used. So you bought capacity for this, but it's not used the rest of the time. If you could use general purpose compute in a cloud cluster, you could actually reuse that compute processing for something else. So let's talk about network processors for wireless, and then I'll wrap up. Here is where we are today. We use, in a typical wireless architecture today, we use a set of FPGAs to do the layer 1 processing. Layer 1 is basically the line-side stuff. It's the physical layer interface with the turbo coding, decoding function, and the FEC line-side interface processing that actually creates the symbol on the line. We use DSPs to actually do some of the channel estimation for that estimation of the quality of various wireless channels and the modulation scheme that should be employed to get the target SINR. It also does the radio link control, is what RLC stands for, and medium access control function, and it also runs the scheduler, where essentially the DSP is deciding which of the subcarriers on the radio interface get allocated to which user for the application that is scheduled based on the packets that are in the queue and the wireless conditions that user is experiencing, because you want to optimize your throughput across all users depending on their conditions. And then on top of that, the CPUs are used to actually do the transport layer, which is actually the tunneling and the encryption back to the core network and the detunneling and de-encryption of that over the core network. So this is the setup today. or actually, so 2010. Here's the 2012. We've actually moved towards using system on a chip, which essentially combine a bunch of DSP CPUs and sort of specialized hardware accelerators to do the layer 1 processing. And so instead of having an array of chips like this, we've actually gone to a 4 times reduction in the number of chips on the board and a 4 times reduction in the power consumption by moving to a system on a chip architecture. With these, we don't actually build ourselves. They're implemented by partners of ours and are becoming industry standards. Components offered widely in this space by Texas Instruments, Freescale, and others. But in future, we see a move towards leveraging the SoC type architecture to actually using general purpose compute for some of the higher order layer 2, layer 3 functions. We'll still retain hardware acceleration for some of the low level symbol creation and phi layer manipulation and channel estimation here. But basically, this will be an evolution. You can think of it as separating the SoC in some way into 2 fundamental components, which is the compute and a specialized hardware accelerator that mixes the current hardware accelerator and a DSP in a specialized component here. So that's where we see things going, and it's all driven by the need to deliver ultra-high capacity, that ATX growth at lower power and lower space. So I'm going to just skip to my conclusion, then I see I've got just a few minutes left for questions, but I'd like to actually entertain your questions for a few minutes if you want to stick around. The basic story here is that no matter what we do, LTE only gets us a factor of 5. But the tablet generation demands much more than a factor of 5. The tablet generation demands a combination of techniques that get us factors of 20 or even 80, as I showed in that modeling study. And so what it takes to get there is, yes, LTE, which is more spectrum and more spectral efficiency, and it does then get a huge kick up by using a small cell architecture. And those SoCs that I highlighted, by the way, are scalable from the macro layer down to the metro layer. So they have to be a family of components. Metro cells typically serve about 64 to 256 users, a macro cell 1,000 users or more. So there has to be a scalable family of components that will allow you to deploy in the macro layer, in the metro layer. You see that Wi-Fi will be an integrated part of that SoC capability in order to get to the price and performance metrics you're looking for. Then there's an adaptive antenna array technique that will give an enhancement on top of that, and then some techniques in LTE Advanced, which is that coherent multipath processing and the interference cancellation. All of that has to be done in those set of components or family of components that scale from the metro layer to the macro layer. So there's a huge amount of innovation that's going to come in the wireless space, let alone talking about doing advanced media processing at the edge. Because one of the questions here is, how do we actually economically afford backhaul for some of these networks? And we want to actually sort of pre-process in some cases or pre-cache some of the content in the baseband in order to more efficiently use backhaul, because backhaul is one of the big constraints on these networks. All right, so there's my talk. What's driving the market going forward is the tablet generation. The value needs to shift from just being device-centric and maybe a little bit of sort of the sex appeal of cloud is coming to the fore, and recognize that it's device, cloud, and network in combination. And the network as a platform of these value layers on top of IP infrastructure, but increasingly the intelligence of those platform layers being built into the IP infrastructure is where we're going, and that creates a demand for highly integrated, highly performing SoCs, network processors, and even general purpose processors to bring this all together and deliver that unique experience. So with that, I'll stop. I would love you to stick around for an extra, say, 10 minutes and just debate me on some of these topics or ask any other questions you would like. Thanks very much.
So we do have a few minutes for questions. Again, approach the microphones. And
yeah, I have a question. I wanted to ask about the potential revolution coming from Google's experiment of putting fiber optics in Kansas City to broad base of homes. And fiber optics at the home introduces a whole new asymmetry of a huge amount of bandwidth at home that can't be reproduced wirelessly. as well as sort of this wild card of what new applications and means of using a huge amount of bandwidth on fiber might change this discussion right here.
Well, first of all, I have to point out that Verizon has deployed 30 million homes of that same technology already. So Google is very good at PR, but they're targeting a few 100,000 homes in Kansas City. Verizon's already deployed 30 million homes of that in the Northeast. So it is actually a technology that's already out there. It's called fiber to the home. It's the Fios brand of Verizon, and Google's is essentially a similar approach. Yes, they say gigabit per second, but it's essentially the same sort of fiber to the home approach. So it is actually already widespread. So your question is very relevant. I'm just pointing out that Google is not in the vanguard here, you could argue. The only interesting thing about the Google thing is that they're getting communities to self-sign up for this, and they will deploy when enough people in the community have bid for them to provide that access, which is not a commercial model that Verizon is allowed to employ. So it's an interesting one because it guarantees you're going to get your revenue, your money back, because they'll only build and once they've got a commitment from the community, whereas Verizon essentially had to, again, take the build in advance and hope they will come. But aside from that, which is sort of a political statement, your question about what will it be used for, well, we can look to what Verizon's already using their network for. They offer now a 300 megabit per second service, I think, over the Verizon Fios service. There aren't actually any new applications, really, that they're offering yet. They are offering a home monitoring service. They are offering a video delivery service, movies on demand service, like a Netflix service that they deliver over a CDN that they own over that network. But as yet, there are not any interesting new services that are being delivered over that ultra-high capacity 300 meg or gigabit per second network. That said, I do think there is a demand I can see for multiple HD streams, multiple HD gaming streams, file upload, download that gets us to a usable 100 to 150 megabit per second using the set of applications that I've illustrated. So it's got communication, streaming, gaming, computing, with latency control. I can see a need for 150 megabit per second per home easily being a number that we would like to support, and that's what I suspect Google will be after too. Now, the nice thing about a gigabit per second is it gives you a very nice peak, and one of these fiber home architectures called PON gives very nice peak performance because you can burst up to about 2.5 gig, which allows you to do very rapid uploads and downloads, because one of the things we're interested in, of course, is if I don't already have it, can I have it sent to me quickly? Or if I have a media object that I want to store in the cloud, I don't want to wait 10 seconds before I leave in order to have that object uploaded. So I think, in my view, the gigabit type capacity is going to be used for very fast upload, download events, not continuous streaming. I think at the continuous consumption level, I see about 100 to 150 megabit per second being the right number. But that's just my view. So the point is, again, we need to get services delivered that users are willing to pay for. And in my view, the new revenue is going to be on the wireless side, albeit delivered over a wireline network with a radio access edge. So that's why I come back to the future is the tablet connected to some sort of network. Whatever I do on that tablet is what I'll want to do on the big screen and also on the mobile phone. And that's the reason I focus so much on that, because I think the monetization is going to be over the mobile device, and the wireline interface is going to be sort of the backhaul of the mobile experience. Does that help in any way?
Yeah, it does. Thank you.
Question?
Rumi Zahir, Intel. Thank you. I really enjoyed your keynote. You mentioned latency and QoS and application-aware, for lack of a better word, plumbing of the network.
Yes.
As value adders. I can certainly appreciate that sitting on my 1.2 megabit download in Menlo Park here. DSL from AT&T. But the question is really, how would you expect that to monetize, or how do you expect application-aware revenue streams? It's the application-aware piece that I'm curious about,
Yeah.
which you did emphasize. And I think you're right, but I can't quite picture an economic model behind that.
I'll give you one model that works already, right? Kindle. Kindle today, you pay for the network portion as a fraction of the book download. So when you order a book for your Kindle, whatever, $9.99 from Amazon, a fraction of that price goes to the network provider. I believe Kindle uses AT&T in the US. And there's an arrangement between Amazon and AT&T where for every transaction over AT&T's network, they get paid. So it's an example of a model. And increasingly, we're seeing that model come to the fore as application developers realize that they need more from the network than just best effort. So if I want to deliver a gaming service over the network, on live, for example, with its gaming service, it needs tight latency control, as we've pointed out. And one way they're doing that is putting their gaming clusters or their GPU clusters at the peering point with operators, but they're even beginning to move them into operator networks. But even then, you need to control the delivery of that over the multi-hops, over the aggregation and access portion of the network, and particularly over the radio access portion. So with that, there will be a similar model that will appear where its application pays network operator for delivery of service. Now, the net neutrality piece gets interesting because in many cases, it's not allowed to be a relationship between application and network operator that is not user initiated. But if user orders premium service from gaming service provider, then there can be a relationship that is user initiated. It's not, the regulation for wireline and wireless is different with the FCC. Wireless is considered a sufficiently competitive and nascent market that it's lightly regulated at the moment. On the wireline side, they've expressly forbidden the relationship existing between an application and a network provider for fear of excluding innovation. But over time, I'm sure that will all work itself out, and the business model will be typically user-initiated ordering of service package that comes with delivery guarantee, and the money will flow like that. And that's why I brought up Mary Meeker's data, is she believes there are many, many, many businesses that will operate under that model to have a guaranteed delivery to part of their digitization process that will actually be transaction-based monetization. I'll quote John Donovan of AT&T, smart man. He says he believes the future gets away from subscriptions and connections. Sorry, subscriptions and minutes to connections and sessions. So he's building his network to monetize ad hoc connections and sessions between people and machines and people and machines and machines. So basically it'll be a very transaction-oriented individual monetization events rather than the subscription model and minutes of consumption that exists today. But this is all up in the air, which is a little bit of the fact we're in a bit of a staring match between the application and content community and the network provider, because no one's willing or no one's been able to figure out the final monetization model that allows the network to be built, the user experience to be delivered, with the total amount of money in the pot remaining the same. The key is the money in the pot is coming from other domains, and that's what Mary Meeker's point is. There's all these businesses that can be reimagined, that the entertainment wallet is not the thing we should be looking at. It's the entire global digital economy wallet. And if that is how if that's the future that we recognize, then there's a lot of money that can still pour into this network delivery mechanism and build that network with the attributes it needs without relying on just typical entertainment dollars to do that. And so I think that's the thing that everyone's sort of getting an awareness for, is this is a new digital economy that we're enabling, not just consumerism. And if that's the case, we should be able to make this the revenue model work. Any other questions?
Chris Kozirak, Stanford University. Thanks for the very interesting talk. I learned a lot. I think the follow-up comment to what the previous question were about was, why don't we let Google and Amazon and Apple build this wonderful wireless network, which I'm convinced we need, since they know how to sell me stuff and make money out of me anyway. Might as well do it as opposed to AT&T and Verizon. Anyway, I don't want you to answer this. That's fine.
It's a nice comment.
So the a little bit lower level question I want to ask is, I want to go back to your picture about the evolution of chipsets. I missed the last step. So you start with 3 or 4 types of discrete chips, and then you go to an SoC right now. And then you want to go back to just a couple of discrete chips.
Well,
and I wasn't sure why you do this last step. Is it because you cannot hit the right balance on a single SoC?
Yeah.
So what's motivating the disaggregation?
Simply put, in my view, is the core processing model is the thing that's going to change the most. Core processing you should think of as the request for a radio bearer with certain attributes and with a certain longevity. It's called core processing because it was voice-centric, but in future, think of it as a bearer processing and scheduling. The volume of requests and the type of requests that's going to have to be handled by the CPU part of that SoC is going to be highly variable and needs to scale in ways that settling on a single SoC design probably limits you to a current view of a call model or a setup model that won't be applicable by the time you've actually deployed it. So we think it's good for now because the core models are actually fairly stable. But in the future, when I'm setting up gaming sessions, communication sessions, compute, streaming sessions, and I'm doing it with a higher order concurrency, meaning more sessions simultaneously with more different characteristics that I have to account for, process, schedule, we think there needs to be more flexibility and scalability in the CPU complex that says actually moving it to sort of a general purpose compute rather than an SoC is probably the right way to handle that very dynamic demand pattern. Maybe that's the best way to put it. You still need hardware acceleration for creation of the symbol on the line because generally even Intel and others who've looked at this say that they even use hardware accelerators when they try and do sort of signal processing for creation of symbols on the line and actually doing the very multiplex of the OFDM and the envelope of that and the D to A and A to D. So I think there'll always be that hardware accelerator for the construction and deconstruction of the symbol, but the scheduling and call processing could move to a cluster of general purpose compute with very dynamic scalability. Does that help?
I think we have time for one brief question. Our speaker has to catch a flight, so.
Yeah, Koji Suginuma from Nihon University, and I completely agree with you about the digital, but still I love Lego. And my question is related to the gentleman other side, and the reason why you want to choose a general purpose processor, I just heard from you, but my question is, what is missing from current general purpose processor from your purpose?
Well, I'm not the one to answer that question. So it was a good question. No, I mean, I think currently the SoC is the best design for us because it has the right amount of compute, the right amount of DSP/hardware accelerator at the right price point for the applications we need. There is, and it's still a debate in the industry, that's why I actually put it as 2017 as the date, is because it's still debatable about how much pooling of baseband processing you can do and how much pooling of the core processing you can do and get reasonable performance out of that. Because if you actually dig down deeply, there are, in each of the layers of L1, L2, L3, there are some very time-sensitive parts of the core processing and not so time-sensitive parts of the processing, and you actually have to get quite deeply into it to see where the dividers, or where the distinctions or delimiters are between those. And so it's a quite sophisticated question to say, what can I do in a CPU with guaranteed performance versus in a piece of hardware with the same sort of, with superior performance versus a CPU. I think there's a sense over time that throwing a massive array of compute at the problem is the right way to do the higher order processing, meaning higher order meaning layer 2, layer 3 type processing, and keep the hardware acceleration functions in dedicated hardware. But it's still a debate in the industry, frankly, so I can't actually give you a good answer on that because the core model is changing, the assumptions about how much has to be handled in a timely fashion in real time and how much it can tolerate a little bit more non-deterministic behavior is something that people are still working through.
Thank you very much.
Okay, well, let's thank our speaker once again.
Thank you very much.